All right, so today we are going to be looking at lesson 4-5. We're going to solve quadratics by completing the square, but first we're going to actually solve quadratics by what's called the square root method. So we're going to start small, work ourselves backwards until you're capable of completing the square. I'm not going to do every problem on here, but all of these problems are worked out and they're under the notes section on my website. So if you want to do extra problems than I did here and check your work, you can go to the notes section and do that there. All right, so before I make this bigger, quadratic equations are the form. So we're going to look at a very simple form of a quadratic. So we've got ax squared plus c. We are going to solve quadratics that don't have the bx term. And so essentially, we're going to take this quadratic, it's going to be set equal to 0. We're going to isolate the x squared term and get some number over here. So we want the x squared term so there's nothing being added or subtracted to it, nothing being multiplied in front of it or divided underneath it. So you just want a plain x squared here. And then you'll end up with some number over here. That number could be positive, negative, it could be a fraction. That's all right. You're going to end up with two answers, a plus or a minus n. So how are we going to do that? These right here are your procedures for doing so, and I'm going to explain each and every one of these as we go through a couple of these problems. So as I stated, you're going to isolate the x squared. Once you get the x squared by itself, you're going to take the square root of both sides, and then you just simplify the radical if you can. And don't forget, and this is big, this is important, that you don't forget to put a plus minus to indicate that there's two answers. And I'll show you why here in a minute. So let's look at number 1. Whoop, there we go. Okay, so as we look at number 1, I need to get this x squared by itself, so I'm clearly going to have to add 64 to both sides. So if I want to isolate that, so I end up with an x squared equals 64. And the reason why we're going to do what we're going to do is this. This is asking for what number times itself twice gives you 64. The majority of you can say, oh, well, that's 8 times 8, so 8 would be the value for x. But there's actually two values when multiplied by itself twice gives us 64, both 8 and negative 8. Because remember, a negative 8 times a negative 8 is also a positive 64. So when we have a squared here, there should be two answers. So in order to solve for x squared, we're going to take the square root, because the square root of x squared is x. If I take the square root of one side, I have to take the square root of the other side. But because I know that there are two answers that make this true, I have to do a plus minus on the side opposite of the x squared. So the square root of x squared is x, and the square root of 64 is 8, but I have a plus or a minus 8. So those are my two answers. Well, what do these answers mean? Remember, we're solving the quadratic. So this tells us what our roots are, our zeros, our x-intercepts, they're all the same thing. These two answers are where the parabola crosses the x-axis. So if this were my xy coordinate, and this were 8, and this were negative 8, my parabola would cross the x-axis at 8 and negative 8. Because the coefficient in front of x squared is 1, and 1 is greater than 0, I know that my parabola opens up. So if I were to sketch this graph, I don't know where my vertex is, but I do know it's somewhere below the x-axis, and this would just be a sketch of it. But this is kind of what it would look like. Again, I don't know where this is. It could be higher or lower, but that's a general sketch of that graph. So I don't want you to lose focus of the fact that the solution that we're finding is where the parabola, which is the graph of these quadratics, crosses the x-axis. All right, so let's do 2. So I am still isolating this x squared term, but this time the x squared has a 7 in front of it. So I still have to subtract 8 from both sides. And I get 7x squared is equal to 7. Then I need to get the x squared completely by itself, so I'm going to divide by 7. And I get x squared is equal to 1. Remember, there are 2 answers that when squared will give me 1. So to figure that out, I'm going to take the square root of both sides, and I'm going to do plus or minus the square root of 1. So the square root of x squared is x, and the square root of 1 is 1. So I have a plus 1 and a minus 1. So this parabola crosses the x-axis at positive 1 and negative 1. So now I've done 2 of them with you. So I would like you to pause the video and do number 3 on your own. You are going to get a fraction answer. Do not give me a decimal answer. But make sure you get the x squared by itself first before you take the square root of both sides. All right, so pause the video and go. Okay, so if you pause the video, you should have gotten a fraction answer, actually 2 fraction answers. So I'm going to subtract 5 from both sides. I get 81 x squared equals 16. I cannot take the square root of both sides right now because there's this 81 in front of the x squared. So you have to take care of that by dividing the 81 to both sides. Now I understand that 16 is not divisible by 81, but remember, if you're not sure how this fraction reduces, you can put 16 divided by 81, enter into your TI calculator, and then hit math enter to check to see if it reduces, and it doesn't. You get 16 over 81, that's its fully reduced form. But I have to solve for x. So to solve for x, I take the square root of both sides. Don't forget that plus minus. So the square root of x squared is x equals plus or minus. I can take the square root of 16 separately from 81. So the square root of 16 is 4, and the square root of 81 is 9. So this parabola crosses the x-axis at positive 4/9 and negative 4/9. All right, so now you've done 3 of them. I want you to do 4, 5, and 6 completely on your own, and then restart the video. Okay, so let's check our answers. So for this one, you should have subtracted 1. Then you should have divided by 8. And then you should have taken the square root of both sides, and again, don't forget that plus minus. Now, a lot of students are telling me that x is equal to plus or minus 2. But you cannot take the square root of 2. It's not a perfect square. Nor can you simplify the square root of 2 because 2 is prime. So since you can't do anything with the square root of 2, you're just bringing it down. Plus or minus the square root of 2. So this is actually your answer. So now that you know that, fix your work on 5 and 6. So pause and fix. Okay, so for 5, you're going to get this by itself, so we're going to add 9. So I get 2x squared is equal to 64. Divide by 2. X squared is equal to 32. Now, when you take the square root of both sides, again, don't forget that plus minus, 32 is not a perfect square, but we can prime factor it. So I'm not going to go through the actual prime factoring of it. I expect you to be able to, choose 2 numbers that multiply to give you 32, 4 and 8, and then break down 8 into its 3 2s and 4 into its 2 2s, so that you realize that, oh yeah, 32 has 5 2s in it. And then we're taking groups. So I'm going to take groups of 2 because my index is 2. So whenever I take something out, I take it completely in front of the radical, not the plus minus sign, but in front of this radical. So right now I have x equals plus or minus, and I'm bringing 2 different 2's out in front, and that 2 is going to remain underneath. So to finish it off, 2 times 2 is 4, square root of 2. There's your final answer. All right, now for 6. So by this time you should be an old hat. Get that by itself, subtract 3. So I get 9x squared is equal to 108. Remember, your calculator is a tool. It will help you with the addition, subtraction, multiplication, and division. So if you don't know how to do it, use your calculator. Oops, that's an x squared. So, oops, and that's not 16 either. Clearly I'm having issues. This is a 12. Okay, so 9 divides into 108 12 times, and so we have x squared equals 12. So now when I solve for x, plus or minus the square root of 12, when you prime factor 12, you will get 2 2's and a 3. So I'm going to take a pair of 2's out in front of the radical, but behind the plus minus. So I get x is equal to plus or minus 2, and then the 3 stays underneath the radical. So that's all that we're going to do for the easier problems. So then let's move on to using a trinomial. So I'm going to go ahead to the next slide. So on this slide, we've got 2 problems here. You can see right here that I have a trinomial and a trinomial, and then I don't really care what number is over here on the right. But both of these trinomials are very interesting to me. This is a perfect square. This is a perfect square. This is a perfect square, and this is a perfect square. So both of these could be perfect square trinomials. It's one of our factoring patterns, and it factors into one set of parentheses squared. So what I would like to do is test each of these to see if they are a perfect square trinomial, and I'm actually going to start with number 2 because it's harder, and I want you to do number 1 on your own, but let's start with number 2 first. So if you recall, the test for a perfect square trinomial is 2 times a times b. So to get a, and I'm just going to back up just a little bit because some of you didn't have my warm-up as part of getting ready for these notes. So remember that a perfect square trinomial is in the pattern, if it is a perfect square trinomial, of a plus or minus 2ab in the middle, and then a b squared at the end. So you have these perfect square bookends, a squared and b squared. One of our tests is to see, does the middle term match this 2 times a times b? The a and b come from taking the square root of these bookends. The square root of a squared is a. The square root of b squared is b. And if that's so, it factors into this one set of parentheses squared with either a plus or a minus in here, and your a and your b are going to go here. So the square root of a squared goes here, the square root of b squared will go here, and then whatever the sign of the middle term is will go in the middle. So each of these 3 will contribute something to the factoring. But I can't just assume that this is a perfect square trinomial. I have to test it. So that's what I'm going to do. So I have my 2, and then I'm going to take the square root of my bookends to find a and b. So the square root of x squared is x, and the square root of 9 is 3. If I multiply these together, 2 times x times 3 is 6x, and that actually matches. I don't care about the sign. Remember, I'll make the sign work, so it does match. So it is a perfect square trinomial, so I know it factors into this one set of parentheses squared, and then I'm going to put equals 20 because that's what's on the right side. So what goes here? Well, you've already done the work. Remember, the x goes here and the 3 goes here. And then to get the sign in the middle, we always look at the sign of the middle term goes here. So because my middle term is negative, I put a negative in the middle. Then I have to solve for x. Well, x is in prison and it's in jail. It's in this jail of this squared thing. So remember, if I cover this up and we just had an x squared equals 20, we'd take the square root of both sides. It's no different. This is still a perfect square. I'm still going to take the square root of both sides, take the square root of this side, and plus or minus the square root of the other side. Now, remember that the index here is 2, and this is written as a power, so all I do is take this index, and theoretically I'm going to divide it to that index there, so I'm really just dividing that by 2. So the square root of x minus 3 squared is just x minus 3. That's it. Equals plus or minus the square root of 20. So then we got 2 more things to do. I have to solve for x, so I'm going to have to add 3 to this side and add 3 to this side. But I have to add the 3 specifically on this side to a very specific spot. I have to add it in front of the plus minus. So I'm going to add 3, because I'm trying to get this by itself, and add 3, but that 3 has to go right here in front of the plus minus. So I get x is equal to 3 plus or minus the square root of. Well, I need to prime factor this 20. So you ought to be able to factor it on your own. That's 4 and 5. And then the 4 is 2 and 2. So I have 2 2's and a 5. And because my index is 2, I'm taking groups of 2 and bringing it out in front. Now that comes in front of the radical but behind the plus minus. So I get x equals 3 plus or minus, I'm going to bring a 2 out in front, and the square root of 5, the 5 stays below. So this is my completed answer. If I've got a radical in the answer, I can't go any further. I can't get 2 different answers. And this radical is fully simplified, so I know that I'm done. Now what I want you to do is try number 1 on your own, just like I did number 2. So pause the video and then check your work. Okay, so we want to test this because, again, this is a perfect square, this is a perfect square. So it could be a perfect square trinomial. So I'm going to test it for 2ab. So I'm going to take the square root of my bookends, so square root of x squared is x, square root of 49 is 7, 2 times x times 7 is 14x, and that matches. So I know that it's going to, the left side is going to factor as one set of parentheses, and it's going to equal 4, because 4 is what's on the right side here. But now I have to figure out what goes here. Again, you've done all the work for that. The x goes here, and the 7 goes here. And then to get your middle sign, look to the middle term for your middle sign, so I'm going to put a plus in here. Then to break x out of that squared parentheses, you have to take the square root of both sides and do plus or minus. So the square root of x plus 7 squared is just x plus 7. It's just your base. Equals plus or minus. The square root of 4 is 2. There should be no radical because 4 is a perfect square, so the radical goes away. There's nothing left under the radical. Then here's where your answer might end up being wrong. I have to solve for x by subtracting 7. Remember, when we subtract 7 to both sides, that 7 gets subtracted in front of the plus minus, not to the 2. So those cancel, and you get x equals -7 plus or minus 2. Now, many of you may have left your answer this way, but there's no radical in the answer, so I can actually go further and figure out what my answer actually is. So I have to actually find out what -7 plus 2 is and what -7 minus 2 is. So in this case, x is going to equal -5, and in this case, x is equal to -9. Again, you can use your calculator to help you out with that. So this parabola crosses the x-axis at -5 and -9. Okay. So you have all the skills necessary to do what is called completing the square. Make this smaller for a minute. Okay. So these are all the processes that we're going to use to do what's called completing the square. So I'm going to go through these fairly quickly and then explain in very fine detail as we go through several examples. So we're going to take a quadratic written as ax squared plus bx plus c. whatever our c is, we're going to put on the right-hand side, because more than likely that constant is not going to create a perfect square trinomial here on the left, which is what we want. The reason why I want that is because I want to be able to have a perfect square trinomial like this on the left, and it doesn't matter what number is on the right, so long as there's a perfect square trinomial on the left. I'm going to show you how to change this constant here by creating your own constant that makes a perfect square trinomial. So if there is a constant here and it doesn't make a perfect square trinomial, you're going to move it to the right by adding or subtracting it. Move it algebraically. Then you will do what's called completing the square. So to do that, write this down and then I'll explain it in a minute. Pardon me for yawning. So our new c is going to equal b divided by 2, and then you're going to square it. That'll all make sense in a minute. Then once you complete the square, you're going to have this perfect square trinomial on the left. So all you have to do is factor it just like we did here, and then you're going to take the square root of both sides just like we did here, and then you're going to solve both equations and simplify any radical answers, which is what we did here and here. And that'll be done. So you have all the skills with the exception of we haven't done this part. So let's put it all together. So I am going to start with number 3 and 4. So I'm going to do 3 and 4 with you. Okay, so the first step says rewrite so that this constant is on the right. So that's what we're going to do. And because right now, the reason for that is 56 is not a perfect square. X squared is, 56 is not. So we're going to remove this over to the right, and we're going to put our own constant here that makes this a perfect square trinomial. So I want to move the positive 56, so I have to subtract it from both sides. And when I do that, I'm going to put these plus blanks on both sides. The reason for the plus blank on the left is because I'm going to create my own constant here to make this a perfect square trinomial. And if I add it on the left, I have to add it on the right to maintain equality. Remember, this is an equal sign, an equation. What I do to one side, I have to do to the other. Okay, so then the next step is to make sure that there's nothing in front of the x squared term other than a 1, and there's not. And I promise you that this is the only type of question I'm going to test you on. Number 4 is a more difficult question. I still expect you to try it and really try to understand it, but I won't test you on number 4. Probably be a bonus question, but I won't test you on number 4. Okay, so there's nothing in front of here for me to divide out, so I'm good with that. Now all that's left is for me to complete the square. So we're going to create our own c by taking b divided by 2 and squaring it. The more times you write that down, the more likely you are to know it. All right, so then you make your template. So instead of b, now bear in mind that this is written differently, meaning I'm not looking at this as b squared and a squared. I'm looking at it in terms of its standard form. Ax squared plus bx plus c. So negative 18 is my b. So I'm going to put my b right here. Now I always put the positive value of b no matter what its sign is, because I'm going to square it. And if I square a negative, I'm going to get a positive. If I square a positive, I'm going to get a positive. The answer that I'm putting here on the blank and that I'm getting for c should always be a positive. So I just ignore the sign. So we're going to put an 18 here and then do the math. 18 divided by 2 is 9, and then square it. You get 81. So an 81 goes on both of these blanks. Now I have created here a perfect square trinomial. There is no need to test it. You created it, you made it so. That's kind of what's nice, is I know it should be a perfect square trinomial. I'm just going to prove it to you right now. The square root of x squared is x. The square root of 81 is 9. X times 9 is 9x. Then times the 2, which is 18x. That's our middle term. So that matches that 2AB test. So I do know that it factors as one set of parentheses squared, and then negative 56 and positive 81 gives me 25. Then to get these pieces that are in here, you're going to have to actually take the square root of your bookends. So the square root of x squared is x, and the square root of 81 is 9. And then the middle term contributes the middle sign, so it's negative, so the negative goes here. Then I want to solve for x. So from here on out, it's what we've been doing. To solve for x, I'm going to take the square root of both sides, plus and minus the square root of 25. I get x minus 9 on the left, and positive or negative 5 on the right. To solve for x, I want to add 9, but remember that 9 gets added in front of the plus or minus, and you get x is equal to 9 plus or minus 5. Because there is no radical in my answer, I have to actually figure out the answer. So 9 and a positive 5 gives me a positive 14. And then 9 and a negative 5 gives me a positive 4. Use your calculator if you're terrible at adding and subtracting integers. All right, so let's do number 4. Now right away, the difference between 3 and 4 is there's this coefficient in front of the squared term. And they've already moved the constant over here on the right for you. We didn't want that constant anyway, it's not a perfect square. But I'm going to divide every term by this 2 to make it go away. So every single term, even the x term, everything gets divided by that coefficient of the squared term. All right, so I end up with x squared minus 8x. I'm going to put in my plus blanks right away, equals negative 15 plus blank. Because remember, I'm going to make my own constant. So C, my constant, is going to be b divided by 2 squared. And my b this time is the 8. And that's going to go here again. I don't care about the sign. So 8 divided by 2 is 4. Squared is 16. So 16 is going on both of these blanks here. Then remember, you know you have created a perfect square trinomial. There's no reason to test it. So it immediately factors as one set of parentheses squared. And then negative 15 and positive 16 is 1. And then you have to figure out what goes in here. So you're going to take the square root of your bookends. So the square root of your bookends are square root of x squared is x, square root of 16 is 4, and then the sign of your middle term goes in the middle, so that's going to be a negative. To solve for x, you take the square root of both sides, and plus or minus the square root on the right. So you have x minus 4 on the left, positive or negative, the square root of 1 is 1. Solve for x, you're going to add 4. And remember, you add 4 on the right side in front of that plus or minus. And so you get x is equal to 4 plus or minus 1. Since there's no radical in the answer, we can figure out what the answer is. So 4 plus 1 is 5. And 4 minus 1 is 3. All right, so our last page. I'm only going to do one problem on this, and actually you're going to do it on your own. So we've done a whole bunch of these together now. I want you to do example 7 all on your own, and this is a typical example that I would test you on. So don't forget, you have to move your constant right here over to the right before you can complete the square. So pause the video, answer this question, and then restart it. Okay, so I want to get rid of this constant, so I'm going to add it to both sides. I'm going to put in my plus blanks because I'm going to complete the square. Then to complete the square, we're going to use b over 2 squared. And my b is 16, so that's going to go here. So 16 divided by 2 is 8. Squared is 64. So 64 goes on each of your blanks. And you have now created this perfect square trinomial, so it should factor as one set of parentheses squared. And on the right side, 16 and 64 is 80. Then you're going to take the square root of your bookends and put them here. So the square root of x squared is x. The square root of 64 is 8. And then the sign of your middle term, plus, goes here. Now take the square root of both sides, plus or minus the square root of 80. You get x plus 8 on the left equals plus or minus the square root of. So I'm going to prime factor 80. If you were to prime factor 80, it's 8 and 10, and then break down 8 and break down 10, you should come up with 4 2s and 1 5. So I'm going to take out 2 groups of 2's out in front of the radical but behind the plus minus. And then I'm also going to subtract 8 from both sides, and that comes in front of the plus minus. So I get x equals -8 plus or minus, and then for each of the groups I have a 2 out in front, and this 5 gets left underneath. So finally I have to actually multiply out the 2 and the 2. So I get -8 plus or minus 4 radical 5. And that's it. Good luck on your homework.